The mystery of catfish skin, from deceptive slipperiness to the colorful world under the microscope. Have you ever wondered why catfish are so hard to hold? It feels like holding a wet bar of soap, doesn't it? It's incredibly slippery. Well, we're going to uncover the mysteries behind that grayish-black skin. Let's get started. Segment 1. Why is it hard to hold? Why is catfish skin so slippery that it's hard to hold? The answer lies in the outermost layer of their body, mucus. The entire surface of a catfish's skin is covered in microscopic glands called goblet cells, whose sole job is to continuously produce mucus. This mucus is composed of glycoproteins and water-loving substances. So, this mucus forms a super slippery gel. In the wild, this mucus also acts as a shield, protecting the catfish from bacteria, fungi, and friction as it moves through rocks or mud. Segment 2. Mysterious gray, perfect camouflage. Why is the skin of most catfish grayish-black? This color is created by pigment cells called melanophores. These cells contain melanin granules, located in the dermis. When the melanin granules are evenly distributed within the cells, the catfish's surface appears pitch black. If the granules are slightly clumped together, the color fades to gray. So why the dark color? It's a camouflage strategy. Catfish live on the bottom of muddy rivers or ponds with minimal light. Their dark bodies blend perfectly with their surroundings, making it difficult for predators to see them. Segment 3. Why is catfish skin easy to peel off? When taking samples for microscopy, the outermost skin of catfish peels off very easily. Sometimes, even just a pinch of tweezers is enough to remove it. Catfish only have a thin, flexible epidermis. With the slightest pressure, this bond can easily break, especially if the fish is dead or the mucus begins to dry, allowing the epidermis to peel off. Segment 4. The paradox of chewy but fragile. Catfish skin is elastic. However, the elasticity doesn't come from the outermost layer that's peeled off, but from the dermis layer beneath. This dermis is filled with tightly packed collagen fibers and a woven fiber network. The thin epidermis tears easily, but the dermis is strong and flexible. When you pull the catfish skin as a whole, it feels springy and stretchy before breaking. Segment 5. Microscopes stage the emergence of hidden colors. With the naked eye, we only see gray and black, but under a microscope, light orange, dark red, and a silver sheen suddenly appear. These colors come from special pigment cells in the dermis layer that were previously hidden by dark melanophores. The orange and dark red colors are produced by xanthophores and erythrophores, cells that contain carotenoid pigments, some of which are astaxanthin. Then, the silver sheen comes from iridophores, cells that contain stacks of guanine crystals. These crystals reflect light, creating a silver mirror-like effect. Segment 6. The mystery of the black spots. We've certainly seen the dark black spots, like spilled ink, from before. These are actually melanophores, and these melanophores are branched. Their branches are filled with black melanin granules. The cells are damaged, and the melanin granules spill out, spreading around the cells, creating a random pattern similar to seeping ink. Segment 7. White is not just a reflection, but a real structure. In some areas, there's a white color, as seen at 1 minute and 48.2 seconds. The white color is the dermis itself, which is composed of thick, dense collagen fibers. These fibers reflect all light spectrums, making them appear white under a microscope. Their silver iridophores also contribute to the reflection of light, adding to the white appearance. Segment 8. Slime factory uncovered. Among the epidermal cells, under a microscope, we will see many clear spheres gathered together, as seen at 4 minutes and 42.9 seconds. They are perfectly round and transparent. Inside, they are filled with mucilage granules, the raw material for mucus. Some have even secreted mucus and formed round sacs that blend with the surrounding water. These are the many factories responsible for making the entire surface of the catfish super slippery. So, these clear spheres are the actual source of slipperiness, which until now we could only feel, but now we can see it directly. Amazing, isn't it? Segment 9, closing. So, now we can put it all together. The seemingly simple skin of a catfish is actually an evolutionary masterpiece. There's mucus for protection and superlubrication, melanophores for camouflage, iridophores and xanthophores for added hidden coloration, and collagen and elastin fibers for strength and elasticity, all arranged in layers that are fragile on the surface but sturdy on the inside. So, the next time you hold a catfish and it tries to escape, remember that beneath its slippery surface lies a complex and beautiful cellular orchestra. If you enjoy scientific explorations like this, don't forget to like, subscribe, and turn on the bell. See you in the next science mystery.